Hello, my name is Beth Dixon, and this is a video where we're going over the Math 0030 final review. That is a typo. And we are on page 5. And let's start, just dive right in and look at number 17. Problems 17 and 18 are one of the most asked questions that I get. We ask this same type of questions in a lot of our classes, and no matter which class they're asked in, this is the most asked question that I get. There is good news and there's bad news. The bad news is this is one of the hardest things I have to explain to students. The good news is it's one of the easiest things to do once you understand what I'm explaining. So I'm going to explain it, and then once you get it, it's going to be really easy to do. But don't worry if you didn't get it the first time, because you're not in that boat alone. Actually, there's no work to do, and I think that's what makes it so hard, because what you're doing is reading the graph. And your teacher has probably really preached, show your work, show your work, show your work. And here there's no work to show, because what we're doing is learning to read a graph, learning to interpret and understand what function notation is and how to use a graph and function notation together. So in number 17, it says use the graph to estimate or to answer the following and to approximate where necessary. And so this graph, the graph itself is the blue in mine where it's in color. Yours may not be blue, it may be black where yours is not in color. So this is f of 2, and so that graph, this parabola that's upside down, is the graph f. So when it says, this would be labeled maybe f of x, showing that it is that f being the graph's name. And then 2 is the input. Whatever's inside the parentheses is the input. Whatever's been written inside is the input. So for this problem, the 2 is the input. The 0 is the input. The -1 is the input. Whatever is inside those parentheses is the input. If we look at this, f is the name, 2 is the input. Have I said that enough? What's inside is the input. And the input is the x values. The input is the x values. Yes, I'm repeating myself because that's the important part of what's going on. So if we look at this, what we're asking is what goes with the input of 2. So if I count over 1, 2, and I hope you can see this. If not, make it really big or spread it out so you can see it. And this is the input of 2, and notice it crosses right there on the axis. So that point right here on the graph has that ordered pair 2, 0. And that 2, 0 is that ordered pair on this function. If I listed all of the ordered pairs on this function, I couldn't list them all, but one of them would be the ordered pair 2, 0. Where x is the 2 and the y is the 0. Do you know what this question is asking? This question is asking, if the x is 2, then what is the output? And the answer is 0. That's all this problem is asking, is to give this y value, this output that goes with this function when the x is 2. So this right here is saying what happens when the x is 0. So when the x is 0, we're not still down at 0. This graph comes up here. And notice it's not a whole number. It is somewhere between 2 and 3. And if I look at that, that looks almost exactly halfway. So I'm going to put that that's halfway between 2 and 3, which would be 2.5. You may look at it and maybe your eyesight's better than mine and it looks like to be 2.6 or 2.4 or 2.75. As long as it's between, it says approximate. Your teacher's not looking for an exact decimal point, just something as a good approximate. And for me, 2.5 is good enough. So we'll go on to the next one. But again, what we're saying before I go on to the next one is that that ordered pair here is 0, 2.5. And if the x is 0, it's asking for that y value. For -1, so I'm going to go to -1, and that's up here at this point. So that's the ordered pair -1, 3. So what is it asking for? F of -1 equals 3. It's just asking for the y value. So as we look at the number 18, our f function is this curve here. This is a cubic. I know that because I've had lots of math and have seen lots of graphs. You don't need to know what it is. It's just a curve. And to find f of 1, all we want to do is count over 1 unit on the x, find the 1, and find out where that graph is. Well, that graph is down here, right there. And that is the ordered pair 1, -1. So f of 1 is the y value, which is -1. F of 0, that means the x value is 0. Where's that graph? Well, it's not up, it's down, and it's right here. And that doesn't quite look like a half. I'm going to call it that ordered pair 0, -0.3. Maybe it's 1/3. I don't know. I'm going to call it a decimal because it's just easier. And again, it said approximate. So if you decided it was something else and it's close to what I got, that's close enough. We're not asking for exact answers there. And I might even put the little I probably should put that approximately there, which is the little wiggly equal signs, because to show that that's not an exact, that's an approximation. Okay, the next one is f of 3. So I want to go out 1, 2, 3. Oh, and that's the easy one because that's 3, 0 as the ordered pair. And so that's 0. And I say that's easy because it's easy for me to see, but it's not necessarily easy for students to understand because it's asking what the y value there is. And sometimes it's hard to see that the y value is 0 because it neither moves up or down. And it's that's a strange concept. So I don't mean to belittle the hardness of it. I just meant that it was easy for me to see that we don't count. When your eyesight is as poor as mine, sometimes it's hard to say that. So then we have f of 4, 1, 2, 3, 4, and we're going to count up until it crosses. So that'd be 1, 2, 3. So we have the point 4, 3. And then that one gives you the answer of 3 because that would be the ordered pair. So you really want to think of these two as kind of looking at the ordered pairs. And if it gives you the x, it just wants you to give the y. And you can almost do it in reverse, and you may have done in some of your equations where it gives you the y and says, what's the x? And so basically it's just a matter of reading the graph for those ordered pairs. Now let's look at the 19, which changes gears. And that's the hard part of the exam too, is that sometimes in the exams you have to remember everything you've done this semester. And if you're doing this the semester that I take this is our quarantined semester and our COVID-19 semester. So this has been a really challenging semester, and know that our hearts go out to all the students and that we're trying to get you as much help as possible. So In number 19, we're going to cross multiply. That's how we solve proportions. And when I cross multiply, I think about what I'm going to multiply, and then I find the variable. I like my variable listed on the left. It's the way I was taught, so it's the way I like to write them. So I find my variable, which is n, and see that it gets multiplied by the 56. So I write 56n first, and then the equal sign. Then I'm going to multiply the other two, which would be 7 times, and I'm going to use my calculator in this video until it is gone, and then I'll have to either see if I can find another calculator or there we go. Find another calculator or see if I can find something to charge this one with. So if it dies in the middle, we may be up the creek. 7 times 40 is the other multiplication there, and 7 times 40 gives me 280. And then I'm going to divide both sides by 56. So that gives me divided by 56, 280 divided by 56. And that gives me n equals 5. And that is how you solve a cross multiplication or proportion problem. And so let's look at the B one on this side. I'm again going to cross multiply. I find my n first because that's just what I do. If your teacher always says to do the top left on the left side, then do that. But I like to find my n first, n times 32, and write 32n. And then the other two numbers, which is 8.2 times 9.6, and that gives me 78.72. And then I'm going to divide both sides by 32. And n equals 78.72 divided by 32. And that gives me 2.46. Hold on just a second. Well, it's a good thing I did this one over. I'm retaping this one, and in the first one I got the wrong answer. 78.72 divided by 32. Apparently I can't type because I got the wrong answer the other time. This time I got 2.46, which is a much nicer answer. Just go with the flow, Beth. Just go with the flow. Now, in problem number 20, before even reading it, I can expect that it be a proportion problem because I just finished some proportions. But if I didn't suspect, how would I know it's a proportion problem? Well, it says if a gas pump fills a 40-gallon tank in 9 minutes, how long will it take the pump to fill a 24-gallon tank? Well, one reason is because it gives me gallons and minutes, then it asks how long, and then it gives me gallons again. Because it gives me gallons and minutes, and then gallons again, and then it's asking for the time, it's a unit, a unit, a unit, and a unit, and it kind of matches up. So what I'm going to do is start, and I always start with the first number in the problem. I'm really kind of OCD when it comes to doing those things, so I just kind of start from left to right. So what's my first unit? The first unit I'm given is 40 gallons. Second unit then is in 9 minutes. So 40 gallons takes 9 minutes. So the next unit I should write should be gallons on the top. So where's my gallons? So I go, how long will it take the pump to fill a 24-gallon tank? So now we're only 24 gallons, and I need minutes down here at the bottom to match up, and that's the find how long, so that would be my X. Now this has units in it and words in it, and I don't want to do a word problem there, so I'm just going to copy that with just the numbers. So 40 over 9 equals 24 over X, and I'm going to work this problem just like I did problem number 19. So that would be 40 times X, and again I find my x first and multiply it by what's across, and that would be 40x equals 9 times 24. 9 times 24, which would be 216. And then divide both sides by 40. And that gives me x equals 5.4. And since my x would be in minutes, that would be 5.4 minutes. Okay, number 21. A 5-foot tall post casts a 4-foot shadow, and a nearby building has a 54-foot shadow. How tall is the building? So I've got a building here, and I'm going to draw my building first. So here's my building, and I don't know how tall it is. So this is the missing piece. And it casts a shadow that is 54 feet long. And then I have a tiny little post, and it's probably even tinier than that, but there's my little post, and it is 5 feet tall, and it casts a 4-foot shadow. So really, I'm asking how tall the building is. Now, I didn't even think about whether it's a proportion problem or not. I just drew the information that was given. And in that, I can see then that I've got the building and the pole and the shadow to a shadow. So I have a building to a 54-foot shadow the way a pole height is to its shadow. And I could have written it the other way with the 5 to 4 first. It wouldn't have mattered. In this case, I drew the building first because in the previous example, I drew the pole first, and then my pole was as tall as my building. And that didn't make sense, so I drew the building first this time. So in this case, I have 4x equals 54 times 5, which is 270. And divide by 4. 270 divided by 4. And that is 67.5 feet. So my building is 67.5 feet tall. Is that reasonable? Well, it is definitely bigger than the 54, and 5 and 4 are fairly close. And so 54 and 67 are a little bit further apart. But relatively speaking, it's probably a very reasonable answer. Now, that concludes this page, and I'm going to stop here to keep these videos at a reasonable length. And if you need to contact me, remember that you can contact me if we're not in COVID-19 by coming by the math lab. But if we're still dealing with COVID-19 or some other pandemic, you can reach me at beth.dixon@ws.edu.